Welcome back to the Pandas module for DataX. Now we're going to be going over the demo, which can be found both linked in the Pandas slides, and it can also be found under lecture materials if you click on code. So this is the demo, and the three things we're going to be going over are data frame creation, reading data in data frames, and data manipulation. So the first thing you have to do is import all the packages you're going to be using. So in this demo, we're going to be using pandas, and we're also going to be using NumPy and matplotlib. So these first two here are just importing those. Next, it's creation of a pandas data frame. So what is a data frame? A data frame basically is two dimensions. It has rows and it has columns, and it's just a way to organize your data. There are also series, which are one-dimensional, and we'll touch on that a little bit later as well. So in a data frame, you can insert almost any data type as an argument. So you can insert dictionaries, you can insert lists, you can insert just normal integers or strings. It's really malleable in terms of what you put inside of it and what you can gain from it. There are also multiple ways to create data frames, and so we're going to go through a few of those. The first one is to create a data frame using an array. Here we have three randomly generated arrays. So just to print those out and make sure that they're all there, they are right here. These are the three randomly generated arrays. And then we can go on to actually create a data frame. So the first thing you do is name it. Here we're doing df0, and we're going to set that equal to data frame, and we're going to call the first array on that. So what we would expect from this is for it to just become a column, since we're only calling one of those arrays. And that's exactly what happens here. We can also print that. We can check the type of it just to make sure that it is a data frame, which it shows right here. And then we can go on to create a data frame from other things. So we can create a data frame from this list right here of A1, A2, A3, the three previously generated arrays. And when we do that, we're actually going to get this entire data frame that has all the arrays we previously discussed. You can also set a column and index name, because if we see here, it's indexed automatically starting at 0 all the way up to however many columns and rows there are. But if you did want to set that yourself, you just do the exact same thing, but you set the columns and you set the indices. And so when you do that, we're just going to see that these get renamed. And it's going to be A1, A2, A3, A, B, C, just like that. You can also add more columns to a data frame if you would like. So here we have the same data frame we've been working with, and we're going to add a column named call4, and that's going to be equal to A2. So what we would expect from that, if we go back up here, is we would expect this to be put into that place. So let's go back down. We'll go right here, and if we see, that's exactly what gets inserted here. We see that this is equal to this. You can also create a data frame from a 2D array. So it's an extremely similar concept. It's just showing that there are lots of different ways to create a data frame. Here again, a randomly generated 2D array, which is displayed here. And if we put that into a data frame using the same structure, naming the columns, naming the indices, we're going to see that it creates a data frame right here. We can also create a data frame using a dictionary. So in the same way that we can use arrays, we can use a dictionary. It's been created for us right here. Just to print that out, we see this. And then let's create a new data frame. So data frame 1, and we set that inside the function, we call dictionary, and we put the indices. And when we call that, it'll have A1, A2, A3, matching the A1, A2, A3 up here, and then the 1, 2, 3, which we added in. You can also add anything, as I was saying previously. So here we have L, which contains its strings, and it also contains integers. And if we do this, it'll just get added to the data frame like a column right here and have list, 3, and blitz. Now we can also create a series similar to what we talked about before, which is just one-dimensional. So the type of data frame 1L would be this column right here. And if we check the type of that, it's actually a series. We can also look at the data type object, and if we do that, we see that a series is an object. We can also see the different data types within a column, just to show that it's perfectly allowed to have different data types and combine them however you may wish. So we have both strings and we also have integers. You can create a series from a Python list. That's just another way to create a series, similar to how we use dictionaries and arrays to create data frames, and it'll just output right here. You can specifically index them and assign them to different series. So this is series 2, but this has the indices A, B, C versus the 0, 1, 2 that we have up here. If you do something like this, you're going to actually select what A is. So we can expect that 2 is going to be returned to us because of this right here. And when we do that, we see that 2 is returned. You can also add the series S to a data frame. So if we take that series column that we had and add that to data frame 1, which we previously created, you'll see that it'll just get added right on here. You can also rename the columns if you would like, and you can delete columns as well. You can also drop columns. So it will not actually change data frame 1, but you won't see it when you're outputting the data frame. So if we dropped A2, we see that it completely skips over it, but it returns a copy so that the original data frame still stays intact. So now that we did that, when we call df1, it's actually going to show back up right here. And so we see that it hasn't disappeared. You can do the same thing with rows. So just an example of that, we dropped 1 and 2 and 3 are still here. Then the next thing you can do is index and slice a pandas data frame. So the first thing we're going to do is just learn how to look at specific columns. And the way we do that is calling the name of that on the data frame. So in this, it'll just output A1. If we do multiple columns, it'll output A1, A3, and so forth. You can keep doing this. If you wanted to slice the first 3 rows followed by the first 2 rows of this sliced frame, you just call it twice. So this is the first command, this is the second command, and when we output it, we're just going to end up with the 2 rows. You can also print the first 2 elements of the column. Doing so will be right here, same as right here. And then you can print the 2 as columns, and to do so, it'll be right here. So that's A1 and A3 versus just A1. Now, instead of indexing like this, what you normally use is loc and iloc. And the difference between these two is that for loc, you get the rows or columns with particular labels from the index versus iloc looks at the position. So it's really looking at labels versus indices and positions. So we're going to start by using iloc. So let's go back again to data frame 1 that we were using. And if we do this, it'll just get the very first at the position 0, 0. So this is what's located at 0, 0, which would be right here. You can also do the same thing and look at the 2nd to 4th row and then the 4th to 5th column. And doing so will output this right here. It'll also accept 2 lists of position numbers. And so doing so will do this. So in this scenario, we're getting A1 and A3 versus what we were doing previously with A1 and A2. You can also specifically choose from rows. You can choose specific index values. You can kind of customize exactly what you want. And so in this scenario, what we're going to be doing is actually just getting data from the first row with the index value of 1, which is shown right here. And these were all of the different columns that there were. Now, if we want to use loc, again, what we're doing is we're using particular labels as opposed to the indices. So if we're grabbing values, we usually want to grab them by the column name, and you have to know both the indices and the columns. So here, what we're going to do is for A2 and A3, we're going to get 1 and 2 since we're going 0 to 2. You can also put constraints on it. So in this scenario, it's returning rows where A2 is greater than 0. If we notice up above, if you look back, one of the rows is actually a negative value. And so when we do this, we'll expect that that won't show up. And it does not. So if we look at A2, the row that has that negative value is not included at all. You can do a similar thing for A3. You can just keep going. You kind of start big and you can end up a lot smaller when you filter through and look for specific types of data. You can also transform that data into other types. So in this scenario, it's changing it to a different type. And when we output that, we'll see that it becomes, it uses NumPy to create this ND array. And the array is right here. So now if we just want some more basic statistics, we're gonna look at describe. And so what describe does is it really just gives a list of all the basic statistic functions that you would want to take a look at. So when we do that, we see it has count, mean, standard deviation, min, all of those things are included. You can also specify that specifically. So if you don't want to necessarily look at the entire data frame, you can index it, choose the parts that you want, and then have that print out just the mean and the standard deviation in this case. You can also change the way that it's sorted with values such as ascending. Here it's equal to false. It'd be different if it was equal to true. And when you do that, you see that it kind of flips the order. So if you want to take a look at more of these statistics, I would recommend checking out the Pandas cheat sheet, which is located over here. So if you take a look under resources, you can find this, and this really goes in, if you go down to the statistics, it goes through all the different functionalities that you can have. So that's definitely nice to look at as well and refer to. So now part 2 is reading data in a Pandas data frame. So usually when you use Pandas, you'll tend to read it in from something, from a CSV file that you already have. So in this case, we're just going to be using this link. You can check that out on your own. But the first thing you need to do is read it in. And the way you do that is pd.readCSV and then include the CSV file there, and it'll just read it in. And now we're going to check the statistics. We're just going to go through some of those statistics that we just looked at. But first, since we haven't seen this data frame, we're going to look at the columns. We see that these are the columns. We can look at head, and head is actually really important in this. And when you're doing Pandas, what head does is it shows the top 5 rows. So when we press enter, we're going to see that it shows 5 rows. It doesn't tell us how long the entire data frame is, how many rows there are, but it does show us the top 5. In the same way, tail shows us the last 5. However, if you put a number in, you can customize what that is. So if we do 2, it'll only show us the last 2. But then if you want it to be something bigger and change it to 10, it'll show the last 10. But just standard, it'll show 5. You can also use group by, and so we have all of these different fields, but if we group by admit and gender, it'll show that it's grouped by admitted, gender, rejected, gender. And since we called sum on that, it shows the frequency. Now, since we transformed the data frame, when we're to describe it, this is what the data frame looks like, as opposed to something like this. We can also call info on it just to get some more specifics. You can look for the unique values. So if we're looking just at department, we can look at that and see there's A, B, C, D, E, F, and go even into more specifics on that. You can also kind of apply all of these concepts together, and you'll get the total number of applicants to Department A. So you're looking at the data frame, then you're looking just at department, then you're looking when department equals A, and you're just looking at the frequency, and then you're summing that all together, which is how you come up with that. Finally, you can also group by the department in general, and then you'll see that A is included as well as the others. Finally, the last little thing that we have is to show the visualizations aspect of Pandas. Now, there are many more visualizations and different graphs that can be created, but we're just going to be creating a bar graph. So here we have the group by department, which is done up here, and we're just going to plot with the bar, and the grid is true. So when we have it, it'll show us the grid, and it'll look something like this. So that's the demo. I would definitely recommend going back and looking more at this. I would also recommend over here taking a look at this Pandas cheat sheet, as it's extremely helpful to have just when you're getting the hang of it, and even later on if there's something you forget, just to take a look at. So I hope you enjoyed that, and I hope it was helpful.